Hello everyone, I got this nice PC Engine LT to try to repair. So owner said it doesn't work. I'm trying first time here, so I power it on, no image, and also the card doesn't even initialize. If it were initializing, you would see some red blinking. So it's absolutely dead, except the power light. So this is the first time I have such a console. It's a rare version of the PC Engine. It's not portable. It does not have a battery compartment. It's transportable, and LT stands for laptop, so it's made for to put on your lap or on a desk. So first time to know opening one. There are five screws, and once you undo them, you can separate the bottom, as you see here. There is one connection for the speaker and two flex cables, one for the screen and one for the control board for the buttons and the D-pad. So you have to be careful not to cut or damage those ribbons. So you have to take some tool and unlock the sockets, as I will show here. You unlock each side. I hope you can see some of it unlocking, and you can remove the ribbon. It will slide effortlessly. So there's some plastic, structural plastic here. You can remove it also. So I'm trying my best to not damage this rare console. Would be a shame if something happened to it. So one ribbon is off, and the second is coming soon. A bit cramped here, but I will make it. A little more effort, and we're almost here. There you go. So the speaker just stuck between two capacitors. Nothing grave, and there you go. So all the capacitors, because capacitors will be a thing on this console too, like many NEC consoles. All capacitors are on this board, the screen, and the control board has no capacitors. So I was examining it, and it was very clean. I was struggling to find any damage, any visible damage from leaking caps. There was someone already attempted some repair on the input side, on the DC input side. There was some capacitor in electric tape that was folded on the board. So we will be removing it anyway. But the main problem is that you have to remove the cartridge port to access capacitors. So here I'll start with the capacitor on the power supply side. First getting the what was like a previous repair. So one is off. You can see some electric tape wrapping it this one. You maybe can't see it, but some pads were already ripped, so that's probably why there was some repair here. Checking for damage. So there was a bit of damage on the board. Two pads were ripped. And now getting rid of the last capacitor, which was one of the original capacitor, not from a previous repair. Adding a bit of flux here, of tacky flux. I use cheap quick flux because it's relatively easy to get in Europe, and Cheap Quick sells it themselves on Amazon. They have their shop, so you know it's original. I tried to get in the past MTech Flux. The first syringe of MTech Flux was great. Then I got two syringes after, and they were either fake, which happens a lot in the electronic flux, or they went cheap and changed the formula and outsourced it to China, because the first syringe was made in USA. The two other were made in China. So for Europe, yeah, I recommend the Cheap Quick. Easy to get and very easy to get a true Cheap Quick and not copy. So this capacitor is a bit resisting a bit. Note that since they are decoupling capacitors, they have each of their legs are on big, usually big planes. So one power plane and one ground plane, which means you have to get some heat to finally get over. So I hope you can see there is some leakage. With the capacitor you couldn't see, but there was some leakage on the board, and the capacitor was faulty, was most likely faulty. So another capacitor to desolder, another through-hole capacitor to desolder. Once again, a bit of flux. Honestly, I could have just used my desoldered gun, which I will use a bit later, but right now I didn't want to just go burr. I just want to take each one by one. So my recording cut here because I didn't know I had a 8-minute limit. So you might have some more cuts like this. I'm sorry. I will try to be careful on the next video. So we'll continue here. I think I had one last through-hole capacitor that I need to remove, and it was so resisting that I went for the desoldering gun. So there's no sound here because I was listening to something else. You will get desoldering gun later. desoldering guns sound later. Don't worry if you like this kind of sound. So heat up. Wonder if I did something. So I will just add a bit more of fresh solder to help do a better thermal conductivity. Checking if the nozzle isn't blocked. But I will get it. Don't worry. Sometimes you just have to heat until the solder from both sides has melted enough so you can suck it. So you can see I'm trying my best. I think I got it. My desoldering gun is set to 385 degrees Celsius, if I remember correctly. Honestly, I could push it a little bit, but at the same time, I don't want to be too hot in case trace of a via has been damaged, and so I prefer to not be too hot. But honestly, it might have been a bit easier with a higher temp. So finally got it, and I think, yeah, you can see it's leaked. It has some electrolyte on the bottom and on the board, so we'll have to clean it. So now the thing I wouldn't do without a desoldering gun is removing the cartridge port, because it blocks access to many capacitors. So yeah, and desoldering it with solder braid, iron, and manual pump would be too long. So here you got a bit of ASMR. I will just let you hear the desoldering gun go burr. So I have finished. Now I will just wiggle the pin around to break any residual solder that might rip a pad. So it is very recommended to do this to avoid breaking ripping a pad or a trace. So everything seems good and unblocked, and yeah, you could see it will come just fine. No damage to pad, no damage to traces, so this is good. And I'll try to show here. You can see there is definitely some capacitor juice that leaked and went from the board on the board. So I'm just wiping it. I will thoroughly clean it later when all the capacitor have been removed. So although the board looked very clean when I opened the console, you can see that there is definitely some capacitor damage. So yeah, don't judge by the look. Always go deeper to repair. Okay, so this one might make you cringe, but this is actually the best method to remove SMD caps, especially old leaky SMD caps. So I saw first this technique on the channel GameTech US, if I remember correctly the name. There will be a link in the description of the channel and a video, hopefully, of demonstrating this. So what you do is you just cut the capacitor flush. You can cut the can or cut under the can if you can, so on the plastic. So you will cut the leg, you will cut the can, you will cut the leg from the board. Then using your soldering iron and your solder braid and a bit of flux, you can easily remove the attached legs without doing damage, or at least the least damage possible on the traces, on the pads. So this might look like a horror movie, but having tried to desolder each leg with an iron, having tried to desolder with hot air, this is really the best method. It isn't 100% safe. If there was a lot of damage on the pads or the traces, you might still rip a pad, which I did on, I think, 2 capacitors, but it's usually fixable with a bit of very thin wire and ideally some liquid solder masks that you polymerize with UV light. Unfortunately, I don't think I filmed the repair of traces. You might find some on MyMateBean's channel. It does this quite a lot. So I will try to find a video with such a repair. MyMateBean's excellent channel too, that does a bit of video game repairs too, among other things, and is very creative sometimes. So you can see, you just snip and usually the pads are fine. Yeah, I didn't want to use hot air to remove because there were plastic connectors. There's a audio jack, the DC jack. There's two potentiometer, one for sound and one for brightness. There's extension port, so there's a ribbon cable. So yeah, I didn't want to use hot air near these plastic parts. So yeah, it is really the best method. So you just remove the remaining plastic part if there are any, and then you dissolve the legs from the pads. You can see I put my thumb just before cutting. I'm not touching the cutter, I'm just putting it above the capacitor so that leg and plastic bits don't fly up in my face or in my eye. That would be a shame. So we finished. So I just didn't record the cleaning of the legs, unfortunately. So once again, I will try to find a video about that on Gentech US channel to illustrate what I'm doing. So here after removing the legs, after desoldering the legs, I cleaned it up with a solder braid to have a clean flat pad. So now I'm preparing all the pads for soldering the SMD capacitors. You might see in the bottom left corner and top left corner that I did some repair with some wire, some thin wire that is stuck in place with some liquid PCB, liquid PCB or liquid solder mask, depends on the terms. So I only have these two damaged, and the damage, there was already some damage on the top left corner, so I would say it went pretty good. So I don't think I recorded absolutely all capacitors. So here I'm trying to fit before the first capacitor I'm trying to fit are the ones that are least accessible. So you can see here there's a plastic jack, there's a controller port, there's a crystal. So it's really not very accessible. So I'm using the classic technique of putting some solder on the pad, taking the capacitor, melting the solder and applying the capacitor on top, and then once it's in place, I will just heat up the other legs and flow solder. And it usually works good. So you can see it's pretty cramped. So I try to not damage the plastic jack. I think I melted a tiny bit, but it's okay. It's aesthetic only. So here I try to position as much as I can. I melt the solder and then I try to press the capacitor on top so it setups. And yeah, I cannot use hot air because of the plastic elements around. So the jack, the controller port with which has a plastic body, and the wheel, potentiometer wheel. So there I heat up both the pad and the leg of the capacitor, and then flow solder. You have to remember, when you solder, you don't solder on the tip of the iron. You heat the elements, and then you put the solder which will melt and flow. And good flux really help to make solder flow. So I think I'm good here. Checking if the capacitor is completely flat. Because sometimes when you do this kind of technique, one of the leg might be on might be not flush on the PCB, might be floating on a little mound of solder, which will be an unreliable connection. So what you can do is once your capacitor is set, you press on top on it and you melt one leg at a time, and you wait between each one of them. So you press. While pressing, you melt the solder on the side. You wait for it to to settle, and then while still pressing you go to the other side and you melt the other legs. Melt the other leg so you're sure the capacitor will sit flush. Some people remove the plastic base of the SMD capacitor. So if you do that, you have access to a bit more of the leg. But I'm not too keen on this kind of technique. So you can see here I'm pushing on top of the capacitor to settle it in place. So when the solder melts, it goes flush against the PCB. Now solder on the other side. A bit of solder is deposited, so I can reflow while pressing, and the capacitor will be flush. So these capacitors are located at very impractical places, so that's why I made them first. I installed them first. So really check in which order you're gonna install the capacitors, because you might install one and then another one will be inaccessible because you installed a previous one. So here you can see there's a capacitor on the side. I can still access it, so that's why I took this order. And there's also a through-hole capacitor that I will install later, because if I install it now, I will not have access to it. So I'm getting to the limit, the 8-minute limit, so video will cut, and it will cut to the first test. So I will just leave you with my live impression. So yeah, that was nice. So then I reconnected everything and powered on, but you can see that the card doesn't initialize properly. So it flashes only one time on power, while there should be other flashes on initialization. So at this point I was suspecting some of the chips went bad. I had a very high suspicion that the CPU was bad, because if it was good it should initialize the card. So I had to ask for a donor white PCE to salvage the CPU. While in the meantime, just in case, I tried to replace the memory chips, because they are the same memory chips that are used on Neo Geo, MVS and AES. So I have a lot of MVS spare boards, and there's the same memory modules used for work RAM, backup RAM, and slow video RAM, if I remember correctly. And so the PC Engine has 3 of these. I changed all 3 just in case, and they were good. I tested them in MVS and they were good. So yeah, it was either the graphic processor or the CPU. So I got a replacement CPU from a donor. Unfortunately, I didn't record the change. So there is a good video about it on Gadget 164, Gadget UK 164, that also did some kind of CPU replacement. and on how to use flux and hot air to remove such SMD device. So I will try to get the link in the description. Also, go and follow him. Very good, very good repairman. Does excellent repair video for on much of the time video games, but on various supports like console and home computers. So yeah, shout out to him. It's a really great, really good channel. So you can see after the CPU replacement how the card initializes. So one flash and then several other flashes. So using the extension port, I can test the console on a bigger screen before replacing things. And you can see in here everything works. Sound, graphics, no bugs, excellent. So here it is. It's completely assembled back. And yeah, everything works. That was a very nice moment. So sound, brightness, controls, everything works. So I was very happy I could complete this repair. The owner was obviously very happy as to getting back a working console, Raritan. A very rare and expensive model. So yeah, and that was the first time I had one in my hands too. So yeah, I was trying my best and was very happy of the results. So thanks a lot for watching. I hope you learned something, like Louis would say. And yeah, try your best to repair what you have. Thank you.